Hello everyone. We're going to present our license plate recognition system using convolutional neural network today. My name is Shizhong Hao and my teammate is Hailin Yu. Here's the outline of our presentation. The dataset we are using is a Brazilian license plate dataset called UFPR-ALPR dataset. And the model we are using to finish each of the tasks is we use YOLO V2 model from darknet to do license plate and vehicle detection, and we use another two character recognition neural network to do classification between numbers and letters. And we apply different weight pruning and quantization strategy to accelerate the overall performance of our network. And we will discuss the findings and the challenges we faced during our project. The dataset we are using is a UFPR-ALPR dataset, which consists of 4,500 fully annotated images of Brazilian vehicles. All of the images are of the same size, 1920 times 1080. All of them are taken by cell phone inside of a moving car. And 40% of data is used for training, 20% for validation, and 40% for testing. However, from the data we got from the TA we got 1,440 for training and 720 for validation and 180 for testing. We did a little data pre-processing to convert the TXT annotation file to the YOLO style annotation in order to train on YOLO network. From a fully, you can see the annotation file is pretty detailed with all the models and cameras, all these kind of things. And we only take the vehicle bounding box and the license plate bounding box and convert it into aspect ratio according to the size of the image. The first column is the class of the object. 0 stands for a car and 1 stands for license plate. The second and third column is the X minimum point and the Y minimum point of the bounding box. And the fourth and fifth column is the width and the height of the bounding box according to the size of the images. YOLO V2 is the model we are using is a YOLO V2. YOLO V2 is a real-time object detection system developed by Joseph Redmond. It has pre-trained weights on ImageNet data to train on customized data sets, and it supports like real-time object detection. It processes images at 48 to 90 FPS and has a MAP on the VOC 2007 image datasets of 78.6% on a GPU, and it works for both image and videos. Here's a full architecture of our YOLO V2 network. We changed the last layer to 35 because we are detecting two classes, which is cars and license plate, instead of the original 425, 420 classes. And we load the pre-trained weight from ImageNet datasets to speed up our training time. and we remove our model cycle data in the middle of our project in order to get better accuracy and a better detection. So we are only focused on cars and car license plate. Alright, here's a couple output of the YOLO V2 network. And the MAP stands for mean average precision. It's the average of maximum precision at different IOU value, while the IOU is the intersection over union. You can see from the figure, it's the area of overlap over the area of union. So usually 50% of IOU can be used as a threshold, and IOU larger than 70% is usually a good detection. The GPU we are using for training and validation and testing is Tesla K80 GPU, which is the free GPU from Google Colab. Here's the accuracy of our YOLO model. The YOLO V2 is the original YOLO V2 model gives us an MAP of 89.13% and an average IOU of 75.94% and both 0.93 precision and record, and the time to detect each images is around 7.64, including this includes the image loading time. And we apply a quantization method to convert all the float 32 weights from the YOLO network to uint 8 weights. However, the accuracy drops pretty significantly. It becomes 75.91% MAP, and average IOU drops to 65.77%, and the precision drops to 0.84. And later we use a YOLO 2 Lite to retrain and calibrate the model to get better accuracy. The GitHub link is here. After retraining the quantized model, the MAP get back to 82.64% and the average IOU of 67.38%, and the precision goes back to 0.88, and the time to processing each images is 6.7 milliseconds. Here's a little example of our output. It produces a bounding box to the object detected, and meanwhile a text file containing all the image name and the confidence score and the aspect ratio of the bounding box according to the size of images is generated for further effort. Now I'll pass the time to Hailin Yu to continue our presentation on character recognition network we got.